The last of our single replacements to notice is the last type of compound. We've talked about things which are covalent. A lot of things are ionic in single and double replacements, but we can also have acids. So we do need to be ready to go back to our acid naming rules as we're looking at these, and I'm going to write both formulas all at once. So we do remember that when we have an ick, we're looking for our polyatomic ion, flip to the back, and we see that we're looking for sulfate or acetate. So now I have an element that's by itself again. I, in this case, have aluminum by itself. I, in this case, have silver by itself. But we may wonder, what can it replace? In the first set, we had a metal replacing a metal. In the second type, we had a halogen replacing a halogen. Well, acids are unique in that they always contain the element hydrogen. So if an acid is reacting, it's because it has a hydrogen in it. And even though hydrogen isn't a metal, we see that it sneaks into our activity series of metals. Hydrogen is over on the left side of the periodic table with all of our metals, so it acts and reacts like a metal in some ways. When we're trying to figure out, can the acid react or not, we are comparing, is the element, specifically the metal by itself, higher or lower than hydrogen on the list? I'm getting very good at that, and I apologize. So we notice that most metals are higher than hydrogen on the list. That means most things, when we put them in an acid, will react. So if I put these together, the aluminum will come in, and it's going to kick that sulfate out, or excuse me, the hydrogen out. It will make aluminum sulfate. And because I already knew my product and I already knew its formula and charge, I was able to do that very quickly. But I was just recognizing that hydrogen comes out, and what do I get when I put an Al with an SO4? The nice thing on these, with all acids, we always will end up with the same product. And like we remembered from the last video, several of our elements are diatomic when they're by themselves. If we're writing the chemical formula for a metal, we just write the symbol of that metal. But for halogens and hydrogen, we do put that subscript of a 2 because it's diatomic. So aluminum, although not highest on the list, by being there kind of in the middle, kind of near the top, is reactive enough to do this. So then we finish out our reaction by balancing it, and we have a nice single replacement. An element with a compound makes a new element and a new compound. In this example, I scribbled, I guess, just in the right places here to see that hydrogen is circled here, but silver is below that. So even though acetic acid is a dangerous acid, especially when our concentration and our strength is really, really high, if we dropped a piece of silver in there, it would not dissolve, it would not react, it would not bubble. In order for a metal to react with an acid, it has to be one of our metals from high up on the list. So as we do our single replacements, we can recognize in all cases it's an element by itself reacting with a compound. In all cases, that element by itself may or may not replace a corresponding element in the compound. We have to flip our periodic table over and look at the chart. Only when the thing by itself is up near the top do we do that. If we are starting with the metal, that metal by itself might replace another metal from the other compound, or that metal by itself might be able to replace a hydrogen. If, however, the thing by itself is a halogen, then we look for the halogen in the compound, and that's how our replacement happens. Although this won't be enough to master the idea of all single replacements, it gives us a strong foundation to get the concept into our skill set.